Solving systems of equations by elimination by Nick, David, and Tiff. We want to solve for the x and y variables. To do this, we want to combine the equations and eliminate a variable to solve for the remaining variable. To do this, both equations must be in the same format. We want to try to eliminate a variable by looking for the same coefficient with different signs. We want to try to eliminate a variable by looking for the same coefficient with different signs. In this equation, we have the 2, 3y's with different signs that we can eliminate to solve for x. Combine like terms to get the new equation, and what we're left with is negative 2x is equal to negative 1. Now that we're trying to get the x by itself, we must divide negative 2 from both sides of the equation. What we're left with is negative 1 over negative 2, which is equal to positive 1/2. Once we solve for x, we can substitute it into any of the original equations. Okay, and we would solve it. 2 multiplied by 1/2 is equal to 1, and our equation is now 1 minus 3y equals 0. Then we're going to subtract 1 from both sides, and our equation is now negative 3y is equal to negative 1. And again, we're going to divide negative 3 from both sides of the equal signs, and we're going to get y is equal to negative 1 over negative 3, or equal to positive 1/3. This equation is now solved, but we do want to double check our answers, so we can double check our answers by substituting in the variables and seeing if the equation is a solution. 2 multiplied by 1/2 is equal to 1, minus 3 multiplied by 1/3 is equal to 1. 1 minus 1 does in fact equal 0. So our coordinate point on the graph will be 1/2 and 1/3. This is where our lines will intersect.